This problem is for you folks to try. We've got the function f of x equals 3x minus 2. I'm asking you to first of all find a formula for the derivative function. That's the function whose output is the slope of the tangent line to this function at a point. And then I want you to find an equation of the tangent line when x is equal to 2. So go ahead, pause the video, and try to work that out. I always like to have a picture if I can, and I know what square root functions look like. I can see for this function, it's going to be defined if this quantity 3x minus 2 is bigger than or equal to 0, because I can't, in the real numbers, take the square root of a negative. That simplifies to x being bigger than or equal to 2/3. So we'll have this point here, 2/3, 0, and it's going to open up and to the right. Now, I didn't spend a lot of time trying to draw that perfectly accurately, and so I'm not claiming that this is drawn exactly to scale. It's not, but it's a rough sketch. And if I want to find a formula for the derivative, I'm going to need to have 2 points. So we'll have x, and then the y value is the square root of 3x minus 2. And then we'll have a nearby point x plus h, and that means that I'm plugging in x plus h for x. So what was I doing to x? Well, I was taking the square root of 3 times my input minus 2. So in these parentheses right here, that's where I'm putting x plus h. Okay. Now f prime of x is going to be the limit as h goes to 0. Okay. So again, here's x plus h. H is just the signed distance between those input values. And we're taking the limit of the slope of the secant line. I can even draw that in. Slope of the secant line is just rise over run, so that's going to be the square root of 3 times x plus h minus 2 minus the square root of 3x minus 2 all over, and again, x plus h minus x simplifies to just h. Okay, so this is the limit as h goes to 0. I'm just going to distribute this 3 inside here, so it's going to become the square root of 3x plus 3h minus 2 minus the square root of 3x minus 2 all over h. And of course, top and bottom are both going to 0, because if I plugged in h for 0, that makes the 2 terms on top the same, and then h is going to 0 on the bottom. So we've got this indeterminate form, and it involves roots. So the way I'm going to simplify that is to rationalize. So I'm going to take these same 2 roots, but I'm going to connect them with the opposite sign. That's going to give me the conjugate, and I'll multiply by 1 in the form of the conjugate over itself. So that's root 3x plus 3h minus 2 plus root 3x minus 2 all over itself. Okay, I'm going to go ahead and erase my picture so that I can bump to the top of the board to keep working on this. So this is going to be the limit as h goes to 0. Now on top, if I FOIL this out, the first terms are just this square root times itself. That's going to lift the radical, so I'm going to get 3x plus 3h minus 2. Outsides and insides are going to be exact opposites, so they cancel. And then my last terms, it's a negative times a positive, so I'm subtracting, and it's this root times itself. So again, that lifts the radical. Do be careful, that gives me the quantity 3x minus 2, and I'm subtracting that whole thing. So again, we're going to have a negative to distribute. On bottom, I'm going to keep that h factored out and just indicate that it's being multiplied by root 3x plus 3h minus 2 plus root 3x minus 2. I'm not going to do the multiplication because I know I'm hoping to be able to cancel that h, so it's easier to keep it factored out anticipating that at some time in the future I'll be canceling it. All right, so this is the limit as h goes to 0. 3x plus 3h minus 2. Let's distribute that negative. So it becomes minus 3x plus 2 over h times this lovely quantity, root 3x plus 3h minus 2 plus root 3x minus 2. Now on top, here's a 3x and a minus 3x. Those are going to cancel. Here's a minus 2 and a plus 2. Those are going to cancel. All that's left on top is this 3h. That's lovely because I'm going to be able to cancel with that h. Okay. Now when we do that, we've got the limit as h goes to 0 of 3 over root 3x plus 3h minus 2 plus root 3x minus 2. Now there's still an h in the denominator, but it's not by itself. Plugging in 0 for h does not make the bottom equal 0. So I can plug in 0 for h. So it's 3 over root 3x plus 0 minus 2 plus root 3x minus 2. Notice now these two terms are the same. They're both just the square root of 3x minus 2. So on bottom, what I have is 2 copies of the square root of 3x minus 2. So that's my formula for the derivative function. 3 over 2 root 3x minus 2. Okay, and I'm not going to rationalize that. I could. Very often what happens when you rationalize is the formula starts to look a little bit more complicated, and this is going to be fairly user-friendly as we move on to part B. Okay. So for part B, I want to find an equation for the tangent line. I know I need two things. I need a point and I need the slope. What I was given was the x value of the point. Well, what's going to go here will be the y value of the point. I get that by plugging into f, the original function. So if I plug in 2 here, I'm getting the square root of 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4, square root of 4 is just 2. For the slope, that's f prime at 2. So I plug into f to get the y value of the point of tangency. I plug into f prime to get the slope of the tangent line. And so that's going to be 3 over 2 times the square root of 3 times 2 minus 2. That's going to be 3 over 4, because we just saw this simplified to 2 times 2 will give us 4. All right, excellent. Now, I've erased my picture. I'm okay with that. I know that what I'm doing when I'm finding the equation of the line is just saying rise is equal to slope times run. And I'm going to use this point, 2, 2, and an arbitrary point, x, y. Okay. So rise is just the difference in y values, that's y minus 2, is equal to the slope, which is 3/4, times the run, which is the difference in x values, and that's x minus 2. If I wanted to simplify further, I could say y minus 2 equals 3/4 x minus 3/2, and then I could add over that 2. So I'd have y equals 3/4 x. See, that's going to be plus 4/2, so it would become plus 1/2. Either version of this line is perfectly acceptable. What is not correct would be y minus 2 equaling 3 over 2 root 3x minus 2 times x minus 2. What I did there is I just said this was a line, but I've got square roots in my formula for a line. That's not possible. I know that lines do not have square roots of variables in their formula. Lines are very simple algebraically. What I need to do is plug in not f prime of x, but f prime at 2. So do make sure that when you're finding the slope of a particular line, it's a number. It's not a function of x. 3/4 was the slope of this line. So I needed to evaluate the derivative function to get the slope for this particular line.